the benefits, again, the benefits to society, being more productive, being safer, and the benefits to the testing industry will be tremendous because we're going to get some new ideas in simulation, in scenarios, lower cost ways to test, incredibly a more number of scenarios because we don't have the time or the money to actually get out there and physically test all of them. So let's start with some of the challenges we're seeing of testing today being addressed by the Warwick Manufacturing Group. So with that, I'm pleasure to bring on stage to join me here, Gunwant, Chief Engineer at WMG. Please join me in welcoming Gunwant. Good morning.
Morning, Shelly. Nice to meet you.
Thank you so much. All right, let's start by telling the audience a little bit about WMG.
Sure. So WMG is a department in its own right at the University of Warwick, established in 1980 by our chairman, Professor Lord Bhattacharya. Really set out a vision to integrate and engage with the manufacturing industry in the UK and to make real impact. So, in its time it's grown. It's now a department that employs over 600 people, which is actually very large for a university department. And, we've worked with industry, and you can see the numbers there, 1,000 large companies and 1,800 SMEs, or small and medium-sized enterprises. And that's a key space for us to be able to enable small startups and companies that want to grow to enable to do that. And of course, education is also key for us at the heart of what we do, and we have master's programs. And I guess over the years, we've had a throughput of over 35,000 students from 75 different countries.
Fantastic. Now, you guys are right in the heart of this connected vehicle space, right? So tell us some of the challenges you're seeing.
Absolutely. So we, I guess, we started the university about 5 or 6 years ago, very fortunate to invest in technologies that enable us to get into this space. And what we saw was there was a real need to ensure systems were dependable. That means robust, reliable, safe, secure, etc., in order for people to want to use them. With the usability, of course, desirability is really important. People want to be able to use these vehicles because they want to use them. Of course, we're all very attached to our own vehicles and we like driving. So how do you pull people away? And so you've got to offer services and products that are going to be attractive. And with that, of course, commercial viability is critical. So one of the things we're really geared up to do is to see how we can accelerate product to market, but also reduce cost. So census, people engaged in this industry, census costs, £3,000 to £5,000 or euros. And that's a lot for an OEM to digest. And so figuring ways of bringing the cost down is a really key thing that we wanted to engage in.
I'm guessing you took the simulation route. So tell us a bit about your simulation approach.
So when we started off, we were looking around to see how we could actually make impact in this space. From our background in test and verification, we saw that everyone was shifting to the left, so more and more virtualization. And then the traditional test environments in the real world existed, from the real world testing on roads to labs, etc. But this middle space where you wanted to do real-time testing using real systems, but in a virtual environment, we could control the environment, didn't exist, especially for CAVs. And so we came up with this idea of a simulator specifically for connected and autonomous vehicles.
Fantastic. I'm guessing the architecture also is really critical because it's a complicated space. So maybe tell us a bit about the software architecture to be able to do the simulation.
Sure. So the architecture was critical. First time we've embarked on it, so we had to make some very interesting, educated guesses. So at the heart of it was to be able to fool a vehicle into believing it's actually being driven in a real environment. So that means you have to start to emulate sensor signals, emulate the environment, create the dynamics model. So we use solutions from XPI simulations, car maker, etc., to create those virtual environments that then feed into a vehicle the real signals. And for the over-the-air transmission, because the communication aspect was critical for us, we use the NIPXI platforms with a range of signal transceivers, the signal generators, and programmable radios to get us that solution where we could do over-the-air transmissions. So, for example, we were able to create a closed-loop system where we could drive around a virtual environment and actually change the satellite constellations dynamically. That means signal strength and the number of satellites visible, etc. So you could actually try and emulate what it would be like to drive in real cities in a virtual environment.
Yeah. I think one thing really interesting that I've learned about this application from Gunwant is they're taking full advantage of some of the 5G technologies even, and I think that that's so critical to bring up in autonomous vehicles.
Absolutely. So 5G is at the heart of what we do in our communications research. So we're working to look at how we do channel emulation, how we can benefit from the speeds that 5G promises, and especially in application, because that's where it's going to make the biggest difference. And of course, the CAV space is ripe for 5G to prosper.
Yeah, exactly. It goes way beyond our devices, right? This technology, this innovation, the prototyping capabilities, the RF are going to expand into transportation. So tell us some of the results and the impact of this.
Sure,
work.
okay. So we're engaged in a large portfolio of research. So we have a program of £200 million a year as a program of research across the whole breadth of everything we do, not just the connected and autonomous vehicles. So impact is really important when we work with industry. So the case here we demonstrate, we've been working with a company called RDM Automotive. Some of you may have seen these pods already. So this is the first foray into autonomous vehicles on the road. And the project was about how we could test or accelerate the testing of these vehicles using a virtual environment, a simulator. So the number there, 300 plus safety relevant scenarios, is an important number because everyone's talking about billions and billions of miles that we have to drive. But actually, it's not the billions and billions of miles that's interesting. It's actually the key scenarios within those miles that are really interesting. So if you can systematically isolate those and recreate them in a repeated and controlled environment, we can actually start to accelerate the testing of these technologies. So simulation environments like this, and the simulator for us has been allowed us to enable to do that.
And I think RDM was pretty happy about the results here.
Absolutely. So you can read the quote yourselves, of course, but David Keane, who's the chairman of RDM Group, for an SME to afford a technology, the simulator for us was a huge investment. You know, it's a £3 million plus investment. It's not feasible. So working with an organization like WMG means that organizations can come to us and really exploit technology whilst being able to accelerate their own development without such huge investments.
I think it's fantastic. Before I let Gunwant leave the stage, I have a little humble brag for him. Last evening, we had the Engineering Impact Awards, Europe-wide, EMEA-wide, and we had the celebration of some incredible applications. But Gunwant and his team actually last evening won Application of the Year through the Engineering Impact Awards, so please give him an extra round of applause. Thank you.
Thank you very much.
For sharing.
Thanks very much, Kelly.
Yes.
Thank you.
Absolutely.